Okay class, so this is an explanation video for number 7 on the practice quiz. This is obviously a very difficult question, and while I'm not going to give you a question that is this involved on the actual exam tomorrow, I do want you to be able to understand everything that's going on in this question. And if you can wrap your head around what's going on in this question, then I think you're really set up nicely for our exam tomorrow. So I'm going to walk you through this. Might take a little bit of time, but we will get through it. So here's the question. I've pasted it in here. We're looking for the mass of sodium hydroxide. So that is our end goal, is a mass of sodium hydroxide. That's what we're looking for. And we've got sort of some other stuff going on here. 75 milliliters of 0.205 molar acetic acid. So here I've drawn my little cartoon. And then I'm going to be adding in OH minus, right? I'm going to be adding in sodium hydroxide. It's a source of OH minus. And then this solution will become a buffer. So initially, right, it's just a weak acid solution. Acetic acid is a weak acid. I'm going to add OH minus. You could almost think of this as a titration problem to some extent, where you're going to be adding in a strong base. That's going to neutralize the acetic acid to some extent, and eventually we're going to be in a buffer region, and we're looking for a buffer of a pH of 4.74. So this right here, buffer with a pH equal to 4.74, that tells me that I'm going to be using the Henderson-Hasselbalch equation. So I know it's a buffer. I'm looking for a certain pH. So in the Henderson-Hasselbalch equation, the pH is going to be equal to the pKa. So in this case, I'm given the Ka for acetic acid, so minus log of 1.8 times 10 to the minus fifth, plus the log of the concentration of the base over the concentration of the acid. Now, in this case, the concentration of the base, that's going to be my acetate ion, C2H3O2 minus, and the concentration of the acid, that's going to be my acetic acid. So the concentrations, right, the molarities of these species, once I've sort of set this reaction up, that's what I'm looking for. That's what's going to be, put in here. And then I'm going to be able to solve this to find, the concentration of the base, the concentration of the acid. So again, this setup, I think this is sort of the first thing that I would do, definitely the first thing I would encourage you guys to do. This sort of grounds me into what I'm looking for. I'm looking for a mass of sodium hydroxide. That's really going to come from this concentration of the base. I have a certain volume, right, that we know of, so that's how we're going to be able to solve this problem. Okay, the first thing that I'm going to do is I'm going to basically, at this point, solve for this ratio of base over acid, right? The only thing that's missing here is my ratio of base to acid. A lot of you might be tempted to put 0.205 in for acid here. Now, that's not a bad idea, but keep in mind that as I add sodium hydroxide in, that's a source of H+, this reaction is going to go, right? I'm going to neutralize this to form water and C2H3O2 minus. And this is sort of my source of acetate ion, right? This base, that is not equal sodium hydroxide, right? This has to be the conjugate acid-base pairs. So weak acid and its conjugate base, that's what goes in here. Really, really important that you recognize that. And this reaction here is going to be sort of what is going on in this equation as I add in OH minus. So what I can do is I can take this top reaction and I can solve for base over acid. And that's going to equal 0.989. So really, what I'm saying here is that my concentration of my base over the concentration of my acid should equal 0.989. Now, it would be really convenient for us if we could just say, well, I know that my concentration of the acid is 0.205. But unfortunately, like I said, because that hydroxide will be neutralizing that acetic acid, I'm not going to be able to get to, I'm not going to be able to just plug that value in for acid. So the way that I sort of went about this is I said, okay, well, if that's the case, let's say that my concentration of base, which is what I'm sort of looking for, right, that's going to help me figure out how much OH minus through how much acetate ion I have. I'm going to call that X. I'm just going to say that my concentration of my base, that will equal to X. Now, this next part is a little tricky. So I'm going to say that my concentration of acid is going to be equal to 0.205 minus x. So let's think about this for a little bit. Let's think about why this is true. My concentration of my base, that's going to be my concentration of acetate ion. That's also going to be the concentration of OH minus, right? What is the source of acetate ion? That source of acetate ion is OH minus, right? This OH minus, whatever I add in, it's going to react with my acetic acid to form our acetate ion. Another key thing about this is that I say assume the addition of sodium hydroxide does not change the solution volume. So that simplifies the problem a little bit, right? Because we can say that my molarity is going to be, based off of this 75 milliliters, even though I'm just adding a little bit of extra volume by adding a solid sodium hydroxide. That's not necessarily going to change the volume all that much. So that simplifies the problem a little bit. So if you're having trouble understanding, what I'm doing here, I guess rest assured that you won't be asked to do this on the exam, but you do, really need to understand what's going on in this problem in terms of why I'm saying that this is my concentrations, where this X value comes from. I'm saying that that's my concentration of acetate ion. The concentration of acetate ion will equal the concentration of OH minus. I really do want you guys to recognize that. And my concentration of acetic acid is going to be 0.205, my initial, minus whatever OH minus I put in there, right? It's going to be consuming that acetic acid. So from here, I can say that X over 0.205 minus X equals 0.989. So if my concentration of base over my concentration of acid equals 0.989, this should hold true. And now I'm going to solve for X. And if I do that, X is equal to 0.102 molar. And now, right, if I just want to check, if I say, okay, well, my concentration of base is equal to 0.102 molar, then my concentration of acid is going to equal 0.205 minus 0.102 is going to equal 0.103 molar. And then the last step would just be to plug those two values in, concentration of base over concentration of acid, to make sure you get 0.989, right? That's going to be the case that my pH will equal 4.74. So the last step here, this X value equals my concentration of base, which in this case, right, equals my concentration of OH minus. I really do need you guys to bear in mind that these are not necessarily the same. In this case, they are. Where my concentration of my acetate ion, that's what is in this Henderson-Hasselbalch equation, that will equal my concentration of OH minus because it's a 1-to-1 ratio, right? That stoichiometry is 1-to-1. So 0.102 molar OH minus. I can then multiply that by 0.075 liters, my solution volume. That's going to give me 7.64 times 10 to the minus third moles of OH minus that I need to put in. And the last step is just converting from moles to grams. So, 7.64 times 10 to the minus third moles of sodium hydroxide, right? I'm asking for the whole mass of sodium hydroxide times 40 grams over 1 mole equals 0.31 grams NaOH. So that, my friends, is the final answer. And again, like I said, I want to reiterate that this problem, a problem like this, you will not be asked to do this. I think this algebra, part here is a little bit tricky, but understanding why, why this works, why I'm putting, concentration of base over concentration of acid, that this is acetate ion, this is acetic acid. I can solve for my ratio. From that ratio, I can, sort of do this algebra trick. And again, this algebra trick is a little bit confusing, right? It's not something I'm necessarily going to ask you. I'm not going to ask you to do this on the exam, but I will ask you to do a similar type problem, right? And understanding what's going on with the Henderson-Hasselbalch equation, that these are conjugate base, conjugate acid. And then here, this is just sort of, doing some math to solve for X, and then converting to grams of sodium hydroxide.